Wavelet family. In Table 2, the most common families are presented. This list is supported by MATLAB copyright. The index is related to the length of the filter, for example, for SIM4 the length is 8. We suggest selecting the base according to the similarity with the biomedical signal. At the most it looks like, better is the representation. In relation to the length of the filter, it is not recommended to use long filters for short time signals. For example, if the time is 10 milliseconds, SIM10 is better than SIM45. Wavelet family. Levels of decomposition. The number of levels of decomposition, N, depends on the relation between the sampling frequency and the bandwidth of the signal. A big N is required if the relation is high. An initial rank can be 3 to 10 levels. Thresholding rule. There are two important thresholding rules applied in most of papers of biomedical signal denoising, soft and hard threshold. However, other rules have been proposed, Keon, 2000. Soft threshold is defined by, Donahoe, 1995. Where Th is the threshold, X is the initial amplitude, input, and Gx is the result, output. In the function is represented. Soft threshold. Hard threshold is defined by, Mallet, 1998. The difference between the soft and hard rules is the output when the input exceeds the threshold. In both cases, the output is 0 when the input is less than the threshold. The function is presented in hard threshold. Results, a case of study of filtering SIMD. The electromyography signal is one of the biomedical signals, which correspond to record of the muscle activity. Because in a typical record, the activity and non-activity regions are acquired and transmitted, it is desirable to clean the signal for improvement the contrast between the two regions. We analyze the relation of the triangle, threshold, energy retained and percentage of zeros. When the threshold increases the percentage of zero increases too, but, the energy decreases. The appropriate point of the triangle corresponds to the maximum percentage of zeros with the maximum energy retained. Experimentally, we found that the 95% of energy retained is adequate for a right interpretation of the signal, Ballesteros and Gauna, 2007, 2008. In Table 2, the results of our study are presented. Results of filtering, N equals 3. Presents the results with different parameters. In the left side, the SIM6 base was used in the decomposition, threshold was equal to 0.26 and the hard thresholding was applied. It obtained the 95% of the energy retained for the 77.5% of the wavelet coefficients set to 0. In the right, the rule was soft. In this case, the 83% of the energy was conserved with the same number of wavelet coefficients set to 0. According to Table 2 and Figure 4, the best combination is Th2 and hard with a SIM6 base. This satisfies the balance criteria. SIMD and its filtered version.